Very good morning, student. Welcome to the SUTHAR'S point. Dear student, today we are taking the Ncert exercise 12.3. This is the fully solved video. You can easily understand how to find the solution of the different important problems of the Ncert books related to the topic area of combination of the plane figure. So dear student, you have already seen what is the meaning of this area of combination of the plane figure, and also you solved some example, and in previous video we already solved question of this exercise from 1 to 5th question number we have already solved. Now next question that is very important, we take question number 6, that is in a circular table cover of radius 32 cm. A design is formed leaving an equilateral triangle ABC in the middle as on the figure. So dear student, we are given this is a table cover in the form of a circle. Clear? Now the design on corner of this table cover is formed leaving this portion as a undesigned, or we can say in equilateral form it is left area. So say you have to find the area of the design. Say area of combination of plane figure. So question what says we are given a circular. So you can say here table cover is in the form of a circle with radius 32 centimeter. O be the center. So we join OB and OC as ABC are vertices of triangle ABC. These are the vertices of triangle, so we join this. Now you can say as we are given OB equal to 32 centimeter, that is the radius is given 32 centimeter. We draw OD perpendicular on BC. See here from the center we draw a perpendicular on BC. As you know that BC is the chord, so perpendicular will bisect this one. So that is BD equal to BC. Clear? So now we try to find the side of the triangle. So we can find the area. Because radius is already given, so we can find the area of the circle. To find the area of the triangle, and this is given an equilateral triangle. So to find the side of this equilateral triangle, we have to use this formula that angle formed at the center is twice the angle at the negative part. So it is the equilateral triangle. That's why angle A will be 60 degree. And central angle will be double of this, that is 120. But we are drawing this perpendicular bisector. So this angle will be 60 degree. BO. So you can say as angle BOC equal to 120 and angle BOD equal to 60 degree. This is by theorem in 9th class you already see. So we get this angle is 60, this is a 90 and angle B equal to 90. Therefore angle OBD equal to 30 by some angle. This is 60 degree, this is 90 and this is 30. Now we can use the trigonometry to find BD. So by trick BD upon BO. So this BD, this is angle we are considering 30 degree, this is 90. So angle considering the side base. So base upon hypotenuse. So BD upon B, base upon hypotenuse, that is cos 30. Base upon hypotenuse. So we get BD we are to find and BO is already given 32 and value of cos 30 root 3 by 2. So one get the BD equal to 32 by 2 root 3 or 16 root 3. Now you know that the BC is twice of BD. So 2 into 16 into root 3. So dear student, you get the BC. That is the side of a triangle. So we get the side of triangle is 32 root 3 centimeter. Correct? Now area of required region, or you can say shaded portion. Area of the shaded portion, which is equal to area of the circle, area of the circle minus area of the triangle ABC. So area of the circle we use formula pi r square minus area of triangle. Now dear student, you can see this triangle is an equilateral triangle, and as you know that area of an equilateral triangle is root 3 by 4 into side square. So you can write here root 3 by 4 side square. Put the values pi as 22 by 7, radius as 32 into 32 minus root 3 by 4 side, that is 32 root 3 square. So you can say 32 square you take common. So here left 22 by 7 minus root 3 by 4 into 3, because root 3 square that is 3. So calculate this one. 32 square 22 by 7 minus 3 by 4 root 3. So 32 into 32, take LCM 28. So 22 into 4 minus 21 upon 7 into 4. So this is 8. So you multiply and simplify. 8 into 2, 16, 1, 25, 256. 88 minus 21 root 3 centimeter square. So this is the required area of the design, because here we are not given the value of root 3 that you have to put. For that reason we are saying required area will be this. So dear student, this is very important, how to find the side of the triangle. So to find the side we have to use the geometry and trigonometry. Both topic we are using here. With the help of that one we find. So now next see, next problem. In the given figure, so here student we are given a figure. A square is given in which 4 circles are touching each other. Clear? Question says ABCD is a square of side 4 centimeter with center ABCD. ABCD. These are the center. With the center ABCD, 4 circles are drawn such that each circle touch externally 2 of the remaining. Like this circle. First, then remaining there are 3. So out of 3, this circle touches 2 remaining circles. Then find the area of the shaded region. Means you have to find this area. And side of this circle is given as 14 centimeter. Clear? So here we write solution. As we given. So we are given the square. So we write here side of the square, that is 14 centimeter, which is also, now very carefully you see, these two circles are intersecting at this point. So distance between their center is the sum of their radius, or we can say that is the diameter also, because each have equal radius. Clear? So we can say AB is also equal to diameter, or each circle, or you can say radii. So radii of each circle are equal to 7 centimeter. Now dear student, we have to find the area of the shaded region. So see very carefully, the required area will be the area of the square minus area of the 4 sector. And we know that in each have angle of 90 degree and radius is 7 for each one circle. So all are equal. So you may write here required area equal to area of the shaded region, area of the shaded region, that equal to area of square, area of the square ABCD minus 4 into area of a sector. One sector, this is sector, this sector, this sector 4. So area of the square minus 4 sectors. So that left only shaded portion. So area of the square, that is formula is side square, minus 4 into area of the sector, pi r square theta upon 360. So side is given here 40, pi 22 by 7, radius is 7, and theta that is 90 degree. Clear? Here this is a square, and you know that in square each angle of 90 degree. So we get 14 into 14. Now this will be 4. So we get this is 7, 22 into 7. Only left 22 into 7. So here you can take common 7 into 2. So left here 14, 2 here 11, left. So 14 into 3. 14 minus 11, 3. So this is 3 for the 12, 1, 3, 1, 4. 42 centimeter square. So dear student, in this way you can find the area of the shaded region. Next we see, so say question number 8, we are given a racing track as you see in the figure, whose left and right ends are semicircles. These two ends, left and right, are semicircles. The distance between two inner parallel line segment is 60 meter. Distance between these two parallel lines is given as 60 meter, and they are each 106 meter. So this distance is given as 106 meter long if the track is 10 meter wide. So this is also given. This is wide is 10 meter. These dimensions are given. So say we have to find the distance around the track along this inner. So you have to find this distance. Distance A, B, C, D, E, F. Clear? So solution see here, AB equal to AD equal to 106 meter. And distance between these two, that suppose we are saying mn, and mn equal to 60 meter. Okay? So this mn will be work as a diameter. This is also we can say 60. Okay? So diameter of each semicircular part is 60 meter. So its radius, that is r equal to 30. So we get the radius. Now first part what says the distance around the inner part. The distance of the inner part of the track. So we want to find the distance how much, that is AB plus this is BCD plus DE plus EFA. So this is the total distance. We have to see this is a straight line. This is also a straight line. So AB has a 106. Now and DE, that is also 106. Now these are two circular parts. Now see very carefully. BCD also equal to AFE. That is the half of circumference of circle, because this is semicircle. So if you take one as a half, but if you take both, that is BCD AFE, that is 2 pi r. This semicircle and this semicircle, so that will be 2 pi r. So you can say 1 by 2 2 pi r, and this is also 1 by 2 2 pi r. So 106 plus 106, 212 plus 2 pi r. Clear? So put the values. 212 plus 2 into pi, 22 by 7, and r is 13. So you can simplify. 212 plus this is 22 44. So multiply 7 14 1 plus multiply this 3 4 12 12 or 13 by 7. So this is 4 4 0 4 8 to 10 1 4 or 3 7 1 8 and 2 by 7. So you can divide 4 0 0 5 approximately meter. So this is the length of inner part. Now second part what says the area of the track. So what is the area of the track? So you can say x, y, z and t suppose. So area of the track means outer part minus inner. So you can say very important, this is area of track is area of this rectangle plus area of this rectangle plus area of two semicircle. Clear? So you can write area of track is equal to area of two rectangle plus area of two semicircular ring. Or you can say now area of a rectangle, that is length into breadth, but we have outer minus inner, outer minus inner. So outer area capital L, length into breadth, minor inner, length into breadth. So this is 2. Twice of outer rectangle minus inner rectangle. Clear? Similarly, area of a circular, that is also you can say area of this semi and this semi, that will make a circle. So outer circle minus inner, you can say outer circle minus inner circle. So now you can say here formula 2 into outer length. Now what is the total length of this one? Outer total length, this is 60 and width is 10. So this is also 10, this is 10. Okay, so you can say area of the outer, this is not only one division, there are no area of two rectangles, but we are combining this. So area of this outer 60 plus 10, 70 plus 80 means area of this outer or this whole part minus area of inner, that will give you this rectangle. Okay, so length will be 106 minus inner length of the both will be 106. So 106 outer length, area of the outer, if you see 106 minus 80, that is 80. This is outer rectangle. Now area of inner rectangle, that is 106 into 60. This is very important. Area of this shaded portion is equal to area of this whole rectangle minus area of this one. Or you can say outer rectangle minus inner. So both have length is same, either outer or inner rectangle. Length is 106, but breadth is same. For outer breadth is 80, 60 plus 10 plus 10, and inner 60. So this. Now plus area of outer circle minus inner circle. If you are combined both circular part, so you can say 2 into here 106 you can take common for easy calculation. This 106 if you take common, then what we get 80 minus 60 plus here you can take pi common. So r square minus r square. So I am writing 2 into 106, that is 212. 80 minus 60, 20 plus 5, 22 by 7. Now you can use formula r plus a, r minus. That we have to. So here see 212 multiplied by 20. That is 4240 plus 22 by 7. Now r plus r into r minus r. So we take radius. So outer radius and inner radius. So here see, we are saying the radius is 30 inner. So outer will be 30 plus 10. That is 40. So we can write here 40 plus 30 and 40 minus 30. So 4240 plus 22 by 7. 70 into 10. So this is 10. So you calculate this one. 4240 plus 22 into 10 into 10. So add this one here to add, you get the answer. So in this way we get the required area. Clear? In this way one can find the area of the required region. So next problem, see question number 9, that is also very important. In the given figure, we are given a figure AB and CD are two diameters. So we are given a circle. In this circle there are two diameters AB and CD. perpendicular to each other. AB and CD are diameter perpendicular to each other and passing through the center O. And OD is the diameter of the smaller circle. And also say here we have one more circle of which OD is a diameter. Then say find the area of the shaded region if OA equal to 7 centimeter. Clear? So here also it is joint B to C. This. And say you have to find the area of this shaded region. This is the shaded region and also this. This is the shaded region. So dear student, in solution we write here we are given only OA equal to 7 centimeter. So its double, that is AB equal to CD equal to twice of OA, which is equal to 14 centimeter. So we can say radius of the larger circle equal to 7 centimeter, which is already given OA, and radius of the smaller circle, that is R, and this we are taking capital R. So radius of this circle we find, because this is the radius of the bigger, which is diameter of the smaller. So this is the radius equal to half of this, that is 7 by 2 centimeter. So we get the diameter. Now you can see required area of the shaded region. So see, area of the smaller circle, we take shaded region area of this smaller. Now we also find the shaded region this. So what is this? This is the semicircle minus area of triangle. Area of the bigger semicircle minus area of the triangle. So we can write plus area of semicircle minus area of triangle ABC. So area of the smaller circle, that is pi r square, plus area of the semicircle. Now this we are taking different radius, capital R, minus area of triangle. This triangle is a right triangle. Here you can take base as AB, which is 14 centimeter, and height, that is OC, which is 7 centimeter. So here you can take pi common. So pi into r square plus capital R square, 1 by 2, base is 14 and height is 7. So pi you can take 22 by 7, small r, that is 3.5, capital R 7, minus 1 by 2, cancel this, so 7. So you get 7 into 7. So what we get, 22 by 7, this LCM 7 by 2 you can take. So that is 7 by 2 square plus 7 square. So minus 7 into 7. So throughout you can take 7 square as a common. So here left 22 by 7 into, this is 7 by 2 plus 1. 7 square we are taking common from here. So minus 1. So this is 49, 22 by 7. This is 4, 11 by 4 minus 1. So calculate this one, 41 into, now 22 and this is 4. That 11, 121 upon 14 minus 4. So you can easily calculate this one. Now in easy form. So 7 to 7. So 7 into this is 1, 11 minus 4, that is 7, 11, 0, 1. 107 by 2. So this is 749 by 2 centimeter. So in this way very easily you can find the value of the area which is the shaded region. Next question see. So dear student, next question see. This is very important. The area of an equilateral triangle is given. So you can write in solution. Here area of the equilateral triangle is given as 1730.5 centimeter square. So if you take if we take side of the equilateral triangle be a centimeter, then we know that area of triangle equilateral triangle formula area of triangle is √3/4 a square. So here we that is 1730.5 centimeter. So we need the side. So 1730.5 divided by √3 into 4. Now also say we put the value of √3 is this. That is 1730.5 into 4 divided by √3. √3 means 1.73205. So this number will be cancelled out. Only decimal that we have to replace 1, 2, 3, 4. Clear? After decimal there are only 1 and there are how many? So I will replace like this 0.1, then in the 10. If we are replacing this 1, 2, 3, 4, 5, then 10 power 5. So what left? 4 into 10 power 4. So a square equal to we get 4 into 10 power 4. If you take square root, that is 2 into 10 power 2. That is 100. So side we are getting 22 centimeter. Now question also say triangle and the center of a circle is drawn with radius equal to half of the side. So this side we are getting 200. Now say the half of this, that is 100 centimeter. And this is equilateral triangle, that's why it is clear. So we can say radius of the circle, that is half of the side of the triangle. So which is 1/2 of 200, that is 100 centimeter. So now required area. Required area of the shaded region. Required area of the shaded region. Then you can say area of a triangle minus area of 3 sectors. Area of triangle ABC minus area of 3 sectors. So you can say area of triangle ABC minus 3 into area of a sector, or 3 sector you can say like this. So area of triangle √3/4 side square, but we take here already given, and area of a circle is pi r square theta upon 360. So area of triangle that is already given. So this is 17320.5 minus 3 into use pi as a 3.14 into r radius, that is 100 into 100, theta as a equilateral triangle, so it is 60 degree. So So you can solve this one, you get the answer. So this will be 6. If you divide this 6 by 2, 3. 6 will divide to 1.57. 3 will be 3. So 1.57 into 100 into 100. So very easy calculation. 17320.5. Now multiply with the 100. 157. Those 2 0 are cancelled. Clear? So you get the answer as after point this is 0. So 5 minus 0, that is 5. 0 minus 0. 2 minus 0, that is 2. 3 minus 13 minus 6. 6 minus 5. 1 and 0. So this is the required area. So in this way we can find it. But it is very important, dear student, that when you need the formula of saddle region, it is important that which area consider. So you can say area of this triangle ABC minus area of this sector, area of this sector, area of this sector. So in the area of a triangle we separate all the three, we get the answer. So that is the required answer. Next we consider. So next is area of combination of the figure we have to find. So here says on a square and cursive 9 circular design, each of radius 7 cm are made. Find the area of the remaining portions. So in solution write, here we are given a square and 9 circles are given, each of radius 7 cm. So dear student, we are given the radius of each is 7. So diameter of 1, diameter of 2, diameter of 3 is 14, 14, 14. Radius of each circular is 7. So diameter of this one 7. That is so 14 plus 14, that is the side. So side of the square, which is equal to 14 plus 14 plus 14, 42 centimeters. Okay? Now we know side and we know the radius. So required area of the handkerchief equal to area of square minus 9 into a circle area. A circle's area or area of circle, right? So area of a square, that is side square, minus 9 into area of a circle, that is pi. Very easy question. We are given side 42 into 42 minus 9, 22 by 7. Radius is 7 for each circle. Clear? So this 7 is cancelled. You may take 7 common and 2 common. Right? So this is 7 and 6, then 2, 21, minus 5 into 11. So 14 into 6, 12, minus 55. So you simplify this, you get the easy answer. In this way you can find the area of the remaining portion of the handkerchief. So next question see, dear student, there say in the given figure OACB is a quadrant of a circle with center O. So we are given a quadrant of a circle. This is with the center O, OACB. This is the quadrant of a circle. And what says, if OD is 2 centimeter, we have a point here with joint this. So this OD is given as 2 centimeter. So say we find the area of the centimeter in this region and the quadrant. This is quadrant, that's why 90. So in solution you write, Here OACB is a quadrant of a circle with center O and radius equal to 3.5 centimeter. That is OA equal to OB, which is we are given 3.5 centimeter, and OD is also given 2 centimeter. Yes. Now question says you have to find area of the quadrant. So area of a quadrant OACD with this whole area. So that is the half of area of the circle. So you can say area of quadrant OACD, that is 1/4 area of circle. Directly you can find 1/4, and area of a circle is pi r square. Clear? R we are taking 3.5. So you can calculate this one. So 11 into 0.5 into 3.5. So to calculate this one, you get the required area of the quadrant. Now say area of the shaded region, this region. So see here, second part we are solving. This is first area of the shaded region. So area of quadrant, OACD minus area of triangle PDO. So area of a quadrant, that we already find this value. So 11 into 0.5 into 3.5 by 2 minus area of triangle. This triangle is a right triangle. So 1/2 base into height. So this can be written as 11 into 0.5, 3.5 by 2 minus 1/2. Here base, that is PO, which is 3.5 as a radius, and height, this, that is already given 2. So you may take 1/2, 3.5 as a common. Then it will be 11 into 0.5 minus 2. So this is 3.5 by 2 into 5.5 minus 2. So 3.5 into 2. If you subtract 2, then 3.5. So this is the centimeter. So in this way, one can easily find this. Clear, dear student? So this is all about the today's class. To be continue with us, we see some more problems. So this is exercise we solved. In next video you see how to solve the exercise of the surface area and volume. So thanks for watching. Have a nice day.